Greetings, everyone. Welcome to your chi-square test tutorial. Chi-square. We use this when we have a hypothesis that we're testing that has two nominal variables or a nominal and an ordinal variable. You probably have a handy-dandy chart for this kind of thing, so please utilize that when selecting the tests that you're going to run. Now, a chi-square test is a test of independence. What that means is we're testing to see if the two variables that we're running our hypothesis test on are independent or dependent. Now, if they're independent, that means your p-value will be larger than 0.05, and you don't have a result, really. Now, if they are dependent, that means the p-value will be less than 0.05, and you do have a statistical association. Oh, note on that. Call it an association. Do not call this a correlation. A correlation is a very specific thing related to Pearson's R or Spearman's rho, neither of which are covered in this video. All right. When we get to SPSS, which we will, we'll stick our independent variable in the row and our dependent variable in the column. What does that mean? Well, independent variable, remember, that's the thing we're saying is causing changes in the dependent variable. So make sure you keep this straight, so it'll make sense why it matters when we get down towards the bottom of this page. But if you are consistent in keeping your independent variable in the row and the dependent variable in the column when you run these tests, I can show you a way to interpret the table that it spits out that is relatively straightforward. So just trust me on this and we'll go with it. Now, again, it is somewhat arbitrary. You could flip these if you wanted, but we'll get there in a minute. All right, so what are we going to ask SPSS to do? We're going to ask it to calculate a chi-square statistic along with the p-value and degrees of freedom that go along with it. And that will determine whether or not these variables are independent or dependent, right? That's the first one. So do you have an association or not? That's always the first question you need to ask when you're running a hypothesis test. Now, the next question you need to ask for all hypothesis tests, not just this one, is the strength of the association. For that, we will use phi or Cramer's V. Now, phi is for a 2x2 table, which is exactly what it sounds like. There are two possible responses for each of the two variables, right? So it kind of creates a 4-cell table. Cramer's V is for ones that are bigger than that. That's that. Now, the example I'm about to do right now, we're going to use phi, but it works actually the exact same way with Cramer. You just use the different number. Now, both of these range from 0 to 1. I think actually phi might go from -1 to 1, whatever. The negative doesn't really mean anything to us. Just know that 0 is a weaker association and 1 or -1, whichever one it may be, is going to be a stronger association. All right. So once we've done this, we will interpret the crosstab table that it generates. The last thing we need to do is actually describe the association using row and total percentages. So, without further ado, let's go ahead and open up SPSS and see what we've got. All right. Let me clear this out so we can generate news. I can show you what we're doing. This here is a data set. All right. This one comes from the General Social Survey, which may be what you're using, or you may be using a data set from a survey that you generated and downloaded the data from Qualtrics. It all depends on who you're taking this course from. Now, this is the data view. Here's the variable view. All right, here you have your variable names, the labels, which in the GSS, the General Social Survey, the labels usually this question itself. We have values, so on, so forth, right? One point that I would like to make right here looking at this variable view, look over here at the measure, right? Don't trust this. SPSS sometimes will mislabel the level of measurement of a variable. It doesn't really know. It's a computer. It only knows what we tell it. So don't trust this. You will need to figure out for yourself if something is ordinal, nominal, or interval/ratio, which is called scale in SPSS, right? So just keep that in mind. Now, this example I'm going to use is a pretty straightforward one. We're going to look at gender differences and attitudes about gun laws, right? It's topical, if not exactly earth-shattering. So we'll go to Analyze. That's where you go to do a chi-square test. You go to Analyze, Descriptive Statistics, and you go over to Crosstabs. That's where the chi-square test lives. Open it up. Now I'm going to clear this out so we can go back and do this all at once. Let me just reset. There we go. All right. This is what it'll look like for you. Now, I don't have a Mac. I'm still working with a Windows machine. But if you're working with a Windows machine, I can tell you, you right-click it and get these radio buttons. Go ahead and hit display variable names. It's a lot cleaner than trying to look at the labels. Now, if you prefer the labels, then don't do that. It's your option. This works for me, though. So, my gender and gun laws hypothesis here. I'm testing a hypothesis that there's a difference. Which one would be the independent variable and which one would be the dependent variable in this? Are we saying that attitudes about gun laws affect one's gender? Or are we saying that one's gender affects attitudes about gun laws? Well, my understanding of reality would favor the second one, right? One's gender influences opinions about gun laws. So in that scenario, gender is the independent variable and gun laws is the dependent variable. So we go back to SPSS. The independent variable goes in the row, and dependent variable goes in the column. Back here. Which one's our independent variable again? It is, well, the GSS calls it sex. It's because the survey's from the 70s. If it had been written, even 20 years later, they probably would have used the correct word for that, but they didn't. So for our measure of male versus female, we're using sex. It's old school, but it's what we have. And we go up here to gun law, put it in the rows. All right. Got it backwards. Try that again. All right. See, this is why it's good to keep things going in one direction, because it's easy to get turned around. All right, again, your row is your independent variable. Dependent variable is the column. Okay. So, sex by gun law. Sounds good. Now we got some other things we need to click first, though. Goes to statistics. This is what we're doing, after all. And we need a chi-square. And we need phi and Kramer's V. There's other stuff here you could click, but why would you? So, we'll hit continue. We'll go to cells. All right. We want the observed counts. Don't worry about the other stuff, the expected and all that other business. But what do we want for percentages? Well, we look here. We want our row and total percentages. So we'll go to row and total. Hit continue. Don't worry about format and style. You can go ahead and hit OK and make the magic happen. So, magic. All right. Look at that. Now, here's your SPS output. There's a lot of stuff here, so let's go through it line by line so you know what to actually report. All right, so what we have here is out of all of our N, our total N of 1,500 people in the General Social Survey, 985 people answered both questions, which is good for about 65.7% of the sample. Not great, but hey. It is what we're working with. Now, how do we interpret this thing? Well, we have men favoring and opposing gun permits 70 to 30, and women favoring and opposing 84 to 16. So that's different, right? But is it statistically significantly different? Well, that's what we find out in our next table. Scroll down, and here we go. Pearson chi-square. That's the chi-square number you're looking for, the 28.25 number. It has 1 degree of freedom, and a p-value, or a chi-square of 28 with a degree of freedom of 1 is going to have a p-value, which is what this is, of 0.000. Asymptotic significance, two-sided, means p-value in SPSS. I don't know why they don't just call it a p-value. My guess is it's to mess with, you. So we have a statistically significant association, right? One's gender does affect one's attitudes about gun permits, which we see here. 70 to 84 is, that's a difference. 14 percentage points. Well, that's pretty significant. But how strong is that? Well, we go down here to phi, because this is a 2 by 2 table. What I mean by 2 by 2, go back up. Favor opposed 2, male, female is 2. All right. So we look at phi. It's a negative. Don't worry about the negative sign, but it's 0.169. That's a lot closer to 0 than it is to 1. So we would call it probably a weak, and maybe for social science data, moderate association. You have to check with your instructor about their kind of cutoffs about this kind of thing. So there you go. That's how you run a chi-square test. To recap, we get our N of 985. That's an important number. I don't even know if I put it on a list before, but it is an important number. And we see here that 70% of men favor gun permits, whereas 84.1% of women favor gun permits. Other things you could take from this table, you can look at total if you want. Total, 78% of people favor gun permits versus 22% who oppose. Interesting, I guess. Let's see here. Your chi-square says it's significant. Not terribly strong, but it is significant. All right. There you go, folks. That's chi-square. Hope you enjoyed that as much as I did.